Alright, ladies and gentlemen, welcome back to the mole stuff. I hope you guys are enjoying it. Probably not, but you should be, or pretend to enjoy it. So the mole things, you already did the grams to mole. Grams to mole, back and forth, moles to grams. So you could do either way, okay? Another way to go is the moles can also go to what we call particles. And these particles could be molecules, atoms, or formula units. Okay. Molecules is for covalent or molecular compounds, so molecular compounds. Atoms are for elements. Elements, you can break it down to atoms. Okay. Formula units are for ionic compounds. So these words should go really well. So if it's an element, it can only ask you for how many atoms are there. If it's a molecule, then they can ask you how many molecules of that thing, or even ask you to break down to the elements, which we will do. And then formula units for ionic compounds like NaCl. How many formula units? Those are not molecular compounds, so they are not molecules. Okay. So today we'll focus on this part right here. We've already done that part, the first part. So in order to do that, we need to know Avogadro's number. Avogadro's number. Okay, Avogadro is a scientist, and he discovered that 1 mole of any element, of anything, is equal to 6.02 times 10 to the 23rd. Okay, particles. All right, so 1 mole is that many particles, and it's just a number, just like a dozen is 12. Right? A dozen is 12. A mole is just 6.02 times 10 to the 23rd particles of anything. So 1 mole of pencils will be 6.02 times 10 to the 23rd pencils. 1 mole of tennis balls is 6.02 times 10 to the 23rd tennis balls. 1 mole of chocolate. What kind of chocolate? Snickers is 6.02 times 10 to the 23rd Snickers. So 1 mole is equal to that. It doesn't matter what it is, okay? So 1 mole is equal to that. The mass, though, is not the same. We already experienced that in the previous time. The mass of 1 mole of, let's say, hydrogen. No, not hydrogen, just diatomic. I don't want to mix that up right now. So 1 mole of carbon is 12.0011 grams. And 1 mole of sulfur is 32.1, something like that. The masses are different, but the number of particles are exactly the same. Okay? So, here it is. Number 1. A sample of 4 moles of potassium. So 4 moles of potassium. Okay, molk. Contains how many atoms? So this is an element. We can find the atoms here. Again, bring the unit down to the bottom. Mole of K. What do we know about mole of K? Well, we want to get to atoms. Is there a relationship between moles and atoms? So then atoms go up on top. 1 mole is 6.02 times 10 to the 23rd atoms. Multiply the top. Okay. You have scientific notation here. So when you enter into your calculator, it's 6.02 times 10. Use a little caret sign here to 23. Okay. If you want to put this in parentheses, that's perfectly fine. You'll type it like that. 6.02 times 10 to the 23rd. When you divide later, you must have parentheses. When you multiply, you don't need to. Okay? So multiply the top and you'll get an answer. Something like 2.408, 2.408, something like that, times 10 to the 24th atoms. I'm trying to do that in my head, but good luck. There you go. You do exactly the same for compounds like on number 4. 3.5 moles of CH4 contains how many molecules? And so this is a compound. It's a molecular compound. So 1 mole of that will equal 6.02 times 10 to the 23rd molecules. Include your units. It is tedious. The units cancel out. All you're left is with molecules of CH4, and that's perfect. Okay, so you multiply that, and you'll get the answer. Pretty simple. And on the right side, right here, funny prisoner skull, silicon. So number 1 on the right side. We start with 8.45 times 10 to the 24th atoms of silicon. So we need to find the mole. How many moles? So we need mole on top. Oh, I'm sorry. Atoms on the bottom here. Atoms SI. We need to bring that down. Make that a habit. So 6.02 times 10 to the 23rd atoms is 1 mole of SI. Now 1 is on top, 1 is on the bottom. When you divide, you have to put parentheses around this thing. If you don't, it's going to divide by 6.02 and then multiply by 10 times 10 to the 23rd. So you don't want to do that. So when you type it in your calculator, you put 4.85 times 10 to the 24th. When you divide, make sure you put parentheses around 6.02 times 10 to the 23rd. When you divide, you must have the parentheses for everything underneath. Okay, and when you do that, you get your answer. And keep it to 1 or 2 decimal places. It'll be mole of silicon. Okay, that's that part. So work on this, guys. Remember to pause it between you jump from one section to another. If you went too fast, too far ahead without pausing, go back and complete the left side before you continue on the right side. And so, the very bottom here, there are 2 more challenging questions. Okay, 2 a little more challenging questions here. So, number 1, one molecule of hydrogen has how many hydrogen? Water has how many hydrogens? 2 hydrogens. How many oxygen? 1 oxygen. So it's asking for how many atoms of oxygens are in 3.5 moles of H2O. Okay. So this is multiple steps here. So 1 molecule of H2O. So we got 3.5 moles of H2O. We need to get 2. So mole of H2O go down here. It's 6.02. 1 mole of H2O is 6.02 times 10 to the 23rd molecules of H2O. And we need to take it one more step. It's asking for atoms of oxygen. So in 1 molecule of H2O, how many oxygens do we have? We only have 1 atom of oxygen. Okay? And that's how you do that. You extend that a little further. Okay? 1 atom of oxygen. That's for number 1 at the bottom. Again, multiply the top, divide by the bottom. If they're 1s, you can skip over it because it doesn't change anything. Alright? So for number 2 here, 1 molecule of glucose has how many atoms of carbon? 6 atoms of carbon, 12 hydrogens, and 6 oxygen. So what do you need to do? You need to you need to start with 4.3 moles of glucose, 4.3 moles of C6H12O6. Okay? And then, let me focus this real quick. That helps a little bit. Alright, and then 1 mole of that, C6H12O6, is 6.02 times 10 to the 23rd molecules. Then 1 molecule of C6H12O6 will have how many atoms of carbon? So we have 6 atoms of carbon per molecule. And then so that's it. We stop there. So we multiply on the top and we'll get divide by 1, we'll get the answer. But again, we don't need to divide by the 1. Again, remember the beauty of this whole grid is that it cancels out all the units. 1 on top, 1 on the bottom cancels out. Top molecule cancels out, and you're left with atoms, and that's what you're looking for. Okay? The last thing on the grid here should be what you're looking for. So, have fun.